Open shortest path first. See, the name has got a big story to know. Open. Here it means this protocol is an industry standard protocol, not a proprietary one. And open, it is also because there is an algorithm called SPF, which is an open standard algorithm. SPF we have learned in various places. Windows programming, if you have done, you might have seen binary tree algorithm. That's what SPF is about. Binary tree algorithm, shortest path first algorithm, or Dijkstra's algorithm. All three are same. We see this algorithm in various places. Microsoft operating system uses it. Every operating system uses it to locate a memory location in a hard disk. This SPF is used. So SPF is just an algorithm, and using this algorithm, a routing protocol called OSPF is developed. So there is no connection between Dijkstra and OSPF. Dijkstra is someone who proposed that algorithm called SPF. That's all. He don't know anything about OSPF. But OSPF is named after that algorithm because it's an open standard algorithm, SPF. And this routing protocol is also an open standard. Algorithm is not routing protocol. Routing protocol is not algorithm. Algorithm is just an idea using which this routing protocol is built. Open shortest path first. Every vendor will have OSPF. That's not the case with EIGRP. It's a proprietary one, Cisco proprietary one. Though Cisco say it as an open standard now, no one is ready to use it again. EIGRP. Only Cisco is using it. No one else have got EIGRP, though it is now an open standard. But OSPF, it's real open standard, right from a small vendor to a very big vendor. You can see OSPF as a routing protocol. It's a protocol of internet, I can say, because not only in enterprises, you can also see in service provider environment, even in data center, there is a protocol called a fabric shortest path first. So even there also you see a shadow of OSPF. That's why I call this as a protocol of internet. OSPF, very popular, equal to ISIS. ISIS is also a popular routing protocol, and both come from same family, link state routing protocol. Link state routing protocol. Both are very popular. ISIS, very nice link state routing protocol like OSPF. OSPF is also a very nice routing protocol like ISIS. What I'm trying to say is they are equally good, equally famous, equally popular, seen everywhere. Yeah. Now, the protocol OSPF comes under link state routing protocol. The reason is using the link state information. Using the link state information, each router will derive best path to remote destination. Using the link state information that is shared between the routers, a router collects link state information from all other routers, and it puts in a database called link state database. Once it has got the complete knowledge of all the links that are connected between the routers. When I say knowledge of all the link, it means the bandwidth on the link, the subnet on the link, the IP address on the link, the OSPF cost on the link, After collecting all this info via an advertisement called LSA, link state advertisement, it forms a big database. It collects all the LSAs coming from all other routers in the environment, forms a big database, and the database will be like a complete map of the connected devices, complete map of the enterprises network or service provider network, complete map of the network. Now, using the complete map, each router can find their own path to reach the remote network by calculating the cost on the path, by comparing the cost on multiple paths. It picks the path which has got low cost. Those things are done using this algorithm. When we have multiple paths, say for example, A has got multiple paths to reach this 1.1.1.1 network. A can find in the database, links to database, two paths, one via B and one via D. So now it calculates the cost via this path to reach 111 and also the path to reach via this path, compares the cost, the path with the low cost path, shortest path, that's what called as shortest path, will be installed into the routing table. So unlike EIGRP, this uses link state routing protocol, link state advertisement, link state protocol. This is link state protocol. This is not a distance vector protocol. This is link state protocol because it uses link state advertisement. Distance vector protocol, if you recall this EIGRP, how it learns route, it learns through advertised distance. Neighbor will advertise its routing table with the metric. By collecting that advertised distance, this router will calculate the FD, feasible distance, and then compare the FD with multiple paths, then decides the best path. That's not the way link state routing protocol works. Link state routing protocol, they don't learn any routing table from neighbor. No. Routers are not advertising the routing table here. In EIGRP in RIP, the routers advertise routing table. That is distance vector protocol. Distance vector protocol will advertise the best route from the routing table and the metric. Link state routing protocol will advertise all the link that are connected and the cost on each link. So EIGRP, when it advertises only the best route, it fails to advertise the other available routes, which means the EIGRP routers cannot learn the complete topology. Whereas OSPF routers advertises each and every link that they have and the subnets on it and the cost on it, which makes the learning router to learn the real topology. I want to repeat this point. Distance vector protocol advertises a routing table. What do we have in routing table? Do we have all possible paths? No. So if only the best path is advertised, the receiving router is not receiving the topology, only partial topology, not the complete topology. Whereas OSPF advertises all link status, bad, good, worst, all link status, all link, nothing filtered, every single link and its information like cost, subnet, IP address, everything is advertised and collected in a big database called LSDB, link state database. After collecting the whole map, complete map, each router position itself in the map and find the best path to reach the remote destination. Say, for example, you are in Amsterdam, the airport, and I am here in the other end called Herlin. Now, if you are going to meet somewhere here in a flower show, and it's a nice place where a lot of tulips grow. I don't remember exact name now. We have decided to meet in this point called Alpha. So now what I have to do, I'm positioning myself in the map here and see what are all the best paths to reach Alpha. You landed in Amsterdam, you position not in Herlin, but in Amsterdam Airport, and you try to find the best path for yourself. So when we have a complete map, we can choose the best path. Then depending on someone's map, EIGRP, they depend on someone's map. Their best path may not be a best path for us. See, for me to come to this place, taking one train may be the feasible one, the best one, but that may not be feasible for you. You don't need to come all the way down here and go here. My path is not the best path for you because you are in a different place. You are in a different location. So distance vector protocol cannot provide accurate information. Distance vector protocol advertises their routing table, their best routes, which may not be a best for the receiver. And not only that, they advertise only the best route, not the complete topology. So no distance vector protocol can have the real complete topology. Though you have a command show IP EIGRP topology, it is not complete topology. Even if feasibility condition is not met, it won't be there appearing in the topology table. So distance vector protocol cannot provide the real topology table. If you don't have real topology table, then you cannot find your best path. OSPF provides the complete topology table called link state database. And this database is complete. So every router position itself, okay, I'm in this location. For me to go to Alpha, these are all the possible ways, and this is the best way. I can pick my own path. Likewise, you can pick your own path from the location where you are now. More accurate path selection can be done only with the link state database, not by using the advertised distance that is provided by EIGRP. An accurate path selection can be made only when you have a complete map. Link state routing protocol alone provides complete map. No other routing protocol provides complete map. Both ISIS and OSPF, they're the only routing protocol that has got complete topology map. Now, secondly, if a path goes down, you saw EIGRP started querying when there is no feasible successor. When the successor path goes down, EIGRP started querying and waiting and stuck in active state. In OSPF, you don't have that story at all. Why? If there is an alternate path, this database will have it. So immediately the routers will swap the traffic through the alternate path from the database. From the database, they immediately take the alternate path when the primary path goes down and they start using it very fast in convergence. If there is no alternate path in the database, which means that there is no alternate path exists. So no need of querying anyone. So OSPF got complete knowledge of topology that results in more accurate path selection plus fast convergence. Switching to an alternate path takes no time because it has got the info already in the database. Immediately, the second path is moved to the routing table and packets are forwarded. That's the best of link state routing protocol. Complete map. It's the topology. How this map is built? By learning link state advertisements. Link state advertisements, link state updates. This all makes the link state database to have an accurate, fine-tuned map, the topology. On top of this database, shortest path first algorithm will run. And for each destination, it is going to see the cost and pick the cost with the low, pick the path with the low cost. Install the path into the routing table. Now, link state routing protocol only can do this. Now, like EIGRP, this also got this three table. Neighbor table, those routers with which OSPF have found parameters matching, like both belong to same area, both belong to same subnet. Okay, come on, let's form a neighbor. If the area ID don't match, they don't form neighbor. So there are certain parameters that's supposed to match when the hello packets are exchanged. When those things matches, they form adjacent, they form neighbor, and those neighbors are listed in this table. The command to see this table is show IP OSPF neighbor. Show IP OSPF neighbor. Now, as I said, topology table has got the complete map of that area, at least. At least within the area, all routers will have identical map, identical database. Yes, OSPF have this two-tier architecture. So we will have multiple areas, and all the areas are connected to one common backbone area. This two-tier architecture helps to scale. Now, we'll talk about those things later. Let's focus here. We got many areas. In an area, all router will have topology table same, identical. Within an area, all router will have identical link state database. Yeah. And then the routing table. Okay, the command to see the topology table is show IP OSPF database. That's the command to see the topology table. There is no command called topology. Next, routing table, we know, show IP route. If you want to see only the OSPF route, you type show IP route OSPF. IP route OSPF. Right. Now, here is the point which we discussed in the beginning. Why link state routing protocol? Link state routing protocol recognize more information about the network than the distance vector protocol. This link state routing protocol routers will have full picture of the topology. As a result, accurate path selection, accurate decision in choosing path can be And not only that, as I said, if the primary path goes down, immediately an alternate path will be taken from the database and put into the routing table for packet forwarding. Advantage of link state routing protocol. And as I said, it is following two-tier architecture, two-level hierarchy. That is for scalability. If if Asia is one country instead of a continent, it is difficult to manage. So what is done is in those olden days, many countries were bordered, formed within Asia, so that managing will be easy and governing, meeting the needs of the people will becomes easier. So when there is a big flood in China, it won't affect people in India, and the government of China will provide all the welfare for those people who are stuck in rain, and people can take the privilege of using it. But it won't be given to India. But in India, because there is no flood in India, because of the boundaries, because of many segregations within the continent Asia, many countries within Asia, it is easy to tackle problems. It is easy to meet the needs of the people. It is easy to govern different policies depending on the location, different policy for different people. You know, so even those who have not done CCNA has got managerial post in Kabul. You cannot enjoy that privilege here in India because of the background. You know, they got the privilege. If Afghanistan is not as a country, then it is not possible to provide that privilege, the people, the privileges for those people who are in need. So depending on the geographical condition, for various reasons, the areas are formed, small areas like India, Pakistan, Nepal, China, Afghanistan. So that helps to govern easily. Likewise, a large network, a big ISP or big enterprises, if all the routers and networks are in one single autonomous system like EIGRP, will not be able to scale well. So many areas when we create, the problems of an area will be localized within that area. The impact will not be seen in the other area. Every small changes, if it impacts the whole topology, not a good design. Problem in Karnataka should not impact all states. So it is good to have states within a country that helps to suppress, that helps uh, to control the problem. The impact is not seen everywhere. Not everyone is crying or suffering when Kerala is in a big flooded situation. No one cares in Andhra Pradesh when Kerala is in flood because of the boundary. It's in Kerala. It's in Kerala. So they are not going to search for a boat in Andhra Pradesh. Who needs a boat is people in Kerala needs a boat. So the government of Kerala need to take care of it because of the area breaking down into small areas. It is easy for the government to provide the needs of the people whenever it is needed. Likewise, to localize the impact of topology change, we need areas so that change in an area will be impacting only those routers in that area, not the other areas. So other areas, CPUs are not unnecessarily disturbed. You see. So what I'm trying to say is OSPF supports unlimited hop count, unlimited. It needs this two-level hierarchy approach. Only then it can provide this unlimited hop count. So there should be some way to scale, and this is the way. Two-level hierarchy, and this is how it is designed. You will have one area called a backbone area, and it is zero only. No other number can be used as a backbone area. That is how OSPF is designed. Now, I got another area, another area. You can have any number of areas connected to this one backbone area. Let's say area 1, area 2, area 3, 4, 5, and 6. Now, inside this area, you may have around 255 networks, another 255 networks, another 200. So you have a lot of areas, and these all areas are connected to this backbone area. Backbone area. Now, this is how OSPF is designed. These non-backbone areas, which is also called as regular areas, they cannot handshake with another non-backbone area. Meaning, if you have a router here and here, they cannot form neighbor. They cannot form neighbor. Even though they are very next routers connected with one wire, even though they have same subnet 10.0.0.1, 10.0.0.2, they can't form neighbor because they belong to different area. OSPF never allows this. Forming neighbor is only with the same area member. Not only that, you see here, this router, we call it as ABR, area border router. The router which has got at least one wire, one port connected to area 0. That is what ABR. This cannot be an ABR. Let's say here it is area 1, and this link is, let's say, right from here it is area 2. Area 2. They won't share. This router is a member of area 1 and area 2. The area 1 routes will not be given to area 2. That is not the way it is designed. It is designed like this. Regular areas can only give routes to transit area. A regular area cannot give route to another regular area. I want to elaborate this one more time. You see this router. This router is member of area 1 as well as area 2. Can this become a ABR? No. We cannot call this as an ABR. Who is an ABR? The router that has got area 0 link, at least one, and non-backbone area links as well. So to understand this, I'm saying this: if area 1 routes are here, this router will not give to area 2 link. Same router, but it won't pass it. Same OSPF process ID, but they won't allow to pass it. They won't share anything between them. Sharing is only with backbone area. So that is how it should go. I have two hands, but no signal passed through my finger of my right hand to finger of my left hand. It always goes through my backbone to the brain and comes to my right hand from the left hand. If my right hand needs help of the left hand needs to talk to the backbone via backbone to the brain, and brain commands my left hand to go and help the right hand. That is how it has to be. even in OSPF. So this setup, this arrangement makes this protocol robust, scalable. All right. So the advantage of having area is to minimize the oh, come on, sorry, to minimize the routing table entry. How, when you have many areas, we can do what? We can summarize the networks and send only the summary. Summarize all the internal network and send only the summary route. When you send the summary route, the receiving area will have minimized routing table. So you get a nice summarization point because of this area. If no area, then you will not have a border. When you don't have a border, then you don't have a area border router. So area is very important to areas are very important to minimize the routing table increase. As I said, localize the impact of topology change within an area. Whenever a change happens in one of the area, it is localized. It is not going to impact the other area. Why? Because you have summarized and sent. So detailed advertisement is stopped in the boundary because you have done summarization. Detailed LSA, you don't need to send, you just send the summary LSA. That is going to reduce the amount of bandwidth utilized as well as the CPU utilized in the topology. As I said, these routers are called as media routers. These are internal to respective areas. This is internal to backbone. This can also be called as backbone routers. Area 0 routers. All right. Stop here.